Lesson 10-6 Surface area of rectangular prisms, and in this lesson you learn to find surface area of rectangular prisms. When are you ever going to use this? Knowing how to find the surface area of a rectangular prism will help you find the amount of paint needed to complete a room. Okay, so the word that we need to know is, of course, surface area. So just imagine the NBA changes the rules so that the basketball is a cube. Dribbling, passing, shooting, everything would be different. The current NBA ball uses about 284 square inches of material. Would they use more or less material to make a basketball that is shaped like a 9 and 1/4 inch cube? Okay, so we'll answer this question in example 3. Okay, so basically, if the basketball is a cube, will it have more or less material to make, okay, than a regular basketball? So let's look at our concept. Concept, of course, is surface area. So the surface area of a three-dimensional object is the total area of its faces and curved surfaces. Okay, so write this definition down. Okay, and in the mini lab, we will construct a prism and find the surface area. So this is surface area of a three-dimensional object is the total area. Okay, again, let me just underline that. It's the total area of its faces and curved surfaces. Okay, so let's take a look at the mini lab right here. Use the measurements shown to draw a pattern like this on a sheet of grid paper. So this is what you need. If you want to do it with me, do it with me. Take out grid paper and start doing this. Or just use 1 centimeter grid paper to be able to draw this. So this is the back, bottom, front, top, side, and side. Okay. Then cut out the pattern along the dark lines. Okay. Fold the pattern along the dashed lines to form a rectangular prism. So basically cut this out and then we form a rectangular prism. Okay, and the rectangular prism form is something like this. Oops, let's see if I can refine it. Nope, not there. Okay, well, we'll try that later. Okay, so find the area of each face of the rectangular prism. So there are 6 faces of our rectangular prism. You have the top and the bottom, you have the front and the back, and you have the 2 sides next to each other. So if you want to find the area of, let's say, the back, okay, that would be 3 units. Remember, you want to find the area of this rectangle, and the area of a rectangle is equal to length times width, or base times height. And this is our height, and this is our base, or this is our width, or this is our height. So the area of this particular face is, or this particular rectangle would be 24 square centimeters. I'm not going to write the unit because just to save space. So this is 24 square centimeters. So if the back is 24 square centimeters, the front is also 24 square centimeters. Okay, the bottom, okay, area would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 8 units across, and you have 5 centimeters as the width, 8 centimeters as the length. Okay, so if I multiply 8 times 5, I'll get 40 square centimeters for the bottom, and obviously the bottom is parallel to the top and they both have the same area, so this is also 40 centimeters. Okay, 40 square centimeters, I'm sorry. And then the side area would be 3 times 5, or 15 square centimeters, and this is also 15 square centimeters. So all we need to do is add them all up. Okay, if we add them all up, I think it's going to be down here. Okay, the top and the bottom 40 centimeters. We measured that. Front and the back 24 square centimeters, sides 15 square centimeters. Add them all up for number 2, it would be 158 square centimeters. So what do you observe about the opposite sides of the prism? How could this simplify finding the surface area? Okay, so I'll give you a formula for this, which is not given in the book. So if you don't watch this video, it's going to be too bad for you. So the surface area, okay, if you follow, okay, our mini lab right there, the surface area of a rectangular prism, this is only true for a rectangular prism, would be 2 times, okay, length times width, which is the top and bottom, plus 2 times length times height, uh, uh, which is the front and back, plus 2 times width times height, which is which are the two sides. I can also simplify this further to become 2 times quantity length times width plus length times height plus width times height. Okay, so you notice this is now the formula for our rectangular prism right here. Okay, so two formulas I gave you, this one and this one, both of them will work. Okay, and let's see how we use this in example number 1. You have a rectangular prism with 7 feet, 8 feet, and 6 feet. Our height is 7 feet, width is 8 feet, and our length is 6 feet. So we can actually, let's use the formula on the left. So let's write down the formula. Surface area equals 2 times the quantity, length times width, plus length times height, plus width times height. Okay, and let's identify our length. Remember, it doesn't matter which is the length, the width, or the height, for as long as it's one of them. 7 feet. Okay, the height is 8 feet, and the width is 6 feet. So it doesn't really matter which is which, for as long as you identify one. Okay, so let's apply this. Let's substitute the values to our formula. So surface area now is equal to 2 times length times width, which is 7 times 6, plus length times height, which is 7 times 8, plus width times height, which is 6 times 8. Okay, again, we need to use order of operations, so we need to simplify what's in the parentheses first before we multiply by 2. So surface area is equal to 2 times the quantity, 42, plus 56, plus 48. Okay, and then we simply add 42 plus 56 plus 48. Do it here. 42 plus 56 plus 48. Add them all up. That is 16. Carry 1, 10, 14. So 146. Okay, so surface area now is equal to 2 times 146, and 2 times 146 is 292. Okay, so the surface area of our rectangular prism, the first one right here, is 292 square, what's the unit again? Feet. So we'll put feet, make it a shorter abbreviation, square feet. Okay, and let's see if we get the same number right here. Okay, so again, in this rectangular prism, opposite sides have the same dimensions, and this is what the book did. So top and bottom 48, okay, front and back 56, and right and left 42, and then they simply added all of them. Look at this one, very similar to the formula. Actually, it's exactly the same as our formula. End up with 292 square feet. And we do the same thing with example 2. So if you can use the formula or you can use what the book used, doesn't really matter which. Opposite sides have the same dimensions. So top and bottom is 15.4 square centimeters. Front and back is 21 times 35 or 7.35 square centimeters. Right and left sides, area is 9.24 square centimeters. And then we simply add the areas using a calculator, end up with 63.98 because we multiply them by 2 as well, like what we did in example 1. Okay? And let's finally go to our last example. Remember what they talked about in our last example? What if the basketball was not a sphere and it's a cube? Okay, would a cube-shaped basketball require more or less material than the current professional basketball? Let's find out. You know that the surface area of the spherical ball, you need to determine whether the surface area of the cube is larger or smaller. So to solve this, we first need to find the surface area of the cube, then compare it with the surface area of the sphere. So in a cube, we know that all 6 faces of the cube, okay, are squares, and we know that each side is 9 and 1/4 inch on each side. Okay, so the surface area of the cube is 6 times the area of one face. So this is our cube, 9 and 1/4 inches per side. Okay, so the area of each face of a face is 1369 over 16 square inches. That's one face, and we simply multiply that by 6, gives us 513 and 3/8 square inches. So the surface area of the spherical ball is about 284 square inches. The cube surface area is greater. It would use more material to make a cube-shaped basketball. Okay, so to check our answer, okay, simply have to find the surface areas of several different cubes with edges between 9-10 inches long to verify that the solution is reasonable. So this particular example brings us also to, oops, sorry, close that, brings us to the formula for finding the surface area of a cube. So remember, we talked about the surface area of a rectangular prism. This is the formula for finding the surface area of a cube. Since all the sides are the same, surface area of a cube is very simple. 6 times s squared. Okay? So 2 formulas I gave you which were not in the book or which are not in the book. So memorize these formulas, write this down in your notes. Okay? And the secret word for this particular lesson is Richard. Secret word is Richard. Okay? Thank you for watching.